We will consider 5 topics in this video. First, midline of a triangle. Second, midline of a trapezoid. Third, area of trapezoid. Fourth, sum of internal angles of any polygon. Fifth, sum of external angles of any polygon. First topic, midline of a triangle. Definition: midline of a triangle is a line segment, in this case triangle ACD, line segment BE. Line segment is that connects midpoints of two sides. B is midpoint of AC, E is midpoint of AD. That was definition. Theorem: midline of a triangle is half of its base. So in this case, our M is half of A. How do we prove it? There are two parts in this proof. First, we have to prove that these two lines are parallel. And we can use a converse of side splitter theorem. In side splitter theorem, we say that if ratio of these line segments and this line segments is the same, then lines are parallel. So this is a converse of that theorem. So, and we clearly see that this is N, this is N, this is C, and this is C. So this line BE is parallel to CD. Part 2. We have to prove actually this formula. Now we can see that triangles ABE and ACD are similar, and therefore corresponding sides of similar triangles are proportional. Therefore, we can easily prove this theorem. Number 2, midline of a trapezoid. Similar to triangle. Definition: midline KL of a trapezoid is a line segment that connects two midpoints of two legs of a trapezoid. So we have trapezoid AF and B, legs FN, AB, midline KL. Also two parts. First, we have to prove that KL is parallel to AF and NB. And we use the proportional line segments theorem. If you remember that in that theorem, ratio of these line segments and these line segments is the same. So the converse would be, if ratio is the same, then lines are parallel. Part 2. We have to prove this formula, that midline of a trapezoid equals half of sum of its bases. And we can easily see that on this diagram that M midline is A first base plus 2 plus S, this little line segment S. And B big base is A plus S plus twice S. If we solve this system for M in terms of A and B, we'll get our formula. Number 3, area of trapezoid. Let's draw MN and let's continue AF to M. We'll have a parallelogram AM and B. So area of trapezoid would be the area of parallelogram minus area of triangle FMN. This is what we have here. Now we use standard formulas for area of parallelogram and area of triangle, and we'll get our formula. Number 4, we get any polygon, any number of sides N. So let's see that. Okay, this is how we prove it. This is how we find the sum of internal angles of the polygon. Let's choose any point F inside that polygon and connect vertices to that point F. We see that we'll get n triangles. Every triangle has sum of internal angles 180 degrees. So the sum of internal angles of a polygon will be 180 for one triangle times n, because we have n triangles, and minus this circle around here, which is 360 degrees. Simplify and we'll get our formula. Number 5, sum of external angles of any polygon. External angles are depicted here. We continue one side, we not consider this 180 degrees angle, so external angle would be here. So in here, alpha is internal angle, beta external angle, and we also have this additional 180 degrees to complete to the whole circle. So what we have here is for each vertex, alpha plus beta, alpha plus beta plus 180, and it will be the whole circle. So how many we have? We have n vertices. So multiply by n. Open brackets. This is this. This is this. 180 times n is this. Simplify and we'll get that sum of the external angles of any polygon equals 360 degrees.